Picture this. You're stepping into a massive, bustling food production facility. You know, the machinery's humming, products are rolling off the line, and everything seems perfectly normal. But hidden somewhere in that giant puzzle of operations, a critical failure has just happened. It's a seriously high-stakes scenario. We're talking public health, brand reputation, and literally millions of dollars are the line here. So today, in this explainer, we're going to treat food safety not just as some boring compliance checklist, but as a high-stakes detective investigation. We're going to see exactly how the industry's absolute best investigators catch the culprits behind these operational failures. So, let's start with a specific crime scene. Say a batch of salad dressing has just tested positive for E. coli. What do? Well, in the past, maybe someone would just toss the batch, blame the machine operator, and move on. But in modern food safety, no way. That is nowhere near enough. We need to know exactly how that contamination happened so we can make absolutely sure it never happens again. We've got to hunt down the real-world operational failure. And that brings us to our main investigative method, root cause analysis, or RCA. Simply put, RCA is a structured, analytical approach used to pinpoint the absolute underlying cause of a food safety incident. The whole goal here is prevention. We are moving way past assumptions, way past the obvious symptoms, to uncover the true culprit of a nonconformance. Okay, let's dive into this. Here is our roadmap for cracking the case. First, the root cause approach. Then, the 5 whys technique. Third, expanding the toolkit. Fourth, when simple tools fail. And finally, meeting regulatory expectations.
Starting with Section 1, the root cause approach, treating incidents as crime scenes. Because, let's face it, our modern global food systems are just way too complex for basic guesswork.
When something goes wrong, whether that's an audit nonconformance or a full-blown product recall, you literally have to treat it like a true crime scene. Just like any good detective, you can't just jump to conclusions, right? You have to follow a systematic process to gather your physical evidence. First things first, you establish a qualified RCA team. You never investigate alone, you bring in the subject matter experts. Then you clearly describe the problem, what happened, when, and where. Next up is analyzing the data. This means rolling up your sleeves and digging into standard operating procedures, deviation logs, environmental monitoring records, the whole lab data shebang. Only after all that can you identify the root causes, take targeted corrective action, and, this is crucial, verify that your solution actually worked. Section 2, the 5 whys technique. The investigator's interrogation. Once you've got your evidence, it's time for our first classic interrogation technique, one that was actually invented by the founder of Toyota. Let's apply this to our salad dressing case, okay? Why did the dressing get contaminated with E. coli? Well, because the ingredients weren't properly sanitized. Okay, but why weren't they sanitized? Because the sanitation procedure wasn't followed. Why wasn't it followed? Because the staff was inadequately trained. Why were they inadequately trained? Because the training program was outdated. And finally, the 5th why. Why on earth was the program outdated? Because there was no regular review and update of the training materials. Boom! There it is. This shows exactly how asking why repeatedly systematically peels back the layers of a problem to catch the true culprit. The issue wasn't just some careless employee, it was a systemic failure in reviewing training materials. Fix that, and you solve the whole case. All right, Section 3, expanding the toolkit, advanced forensics. Because while the 5 whys is a fantastic starting point, highly complex mysteries require a much broader set of forensic tools. So one of those advanced tools is the Pareto principle. You've probably heard of this. It's that visually striking concept that roughly 80% of your effects, so your nonconformities or food safety incidents, usually stem from just 20% of your causes. Think about it. If you see a massive spike in complaints, you gather your data, chart it out, and identify your vital few causes. By focusing your corrective actions on that critical 20%, you are effectively solving the vast majority of your problems in one go. Next up, we have the fishbone, or Ishikawa diagram. Think of this as your forensic whiteboard. When you have a problem, say insufficient cleaning in hard-to-reach areas, you map that out right at the head of the fish. Then, you draw bones representing the main causes, things like equipment, people, or management. From there, you branch out into secondary causes, maybe a lack of detailed cleaning tools or incomplete cleaning instruction cards. It's a brilliant way to visualize all these interconnected categories of contributing factors so you can formulate a really targeted corrective action. So what does this all mean? The crucial takeaway is knowing which tool to pull from your kit and when. The 5 whys, that's your go-to for simple, linear problem solving. The Pareto chart, that's for prioritizing your most frequent issues. The fishbone diagram is absolutely perfect for visualizing multiple categories of causes. And tools like the K-Knot chart help your team categorize what's known, what you still need to know, and what's honestly just an opinion. Because every crime scene is different, and they all require totally different strategies to solve. Section 4. When simple tools fail, the plot twist. Now, what's really interesting about this slide is that while we've talked about how great these simple tools are, relying on them too heavily can actually sabotage your investigation. Let's contrast a single root cause focus with complex systemic factors. The fatal flaw of the 5 whys method is that it forces you down this single, linear analytical pathway. It assumes there's only one culprit hiding in the shadows. But the reality? Major food safety incidents, like a massive, multi-state product recall, are almost never the result of a single isolated error. They're almost always the result of multiple, interconnected, complex systemic failures. Let's break those limitations down a bit more. Because the 5 whys relies so heavily on subjective investigator bias, you could literally have two different teams look at the exact same contamination and come up with two entirely different root causes just based on their own backgrounds. It also frequently leads teams to stop at the first plausible cause. Actually, scratch that. It's more like they just stop at the first plausible cause without actually validating it with data. Using only the 5 whys on a massive, complex food system failure is going to leave you with some massive, incredibly dangerous blind spots. Section 5. Meeting regulatory expectations. Answering to the police chiefs. Okay, so we have our evidence. We found the true systemic causes. Now we have to present our case to the ultimate police chiefs, the regulatory bodies and certification auditors who demand these cases be closed permanently to protect public health. Take a look at the SQF Edition 9 guidance document. It explicitly states that a documented root cause analysis is mandatory evidence for every single major nonconformance. When an auditor finds a deviation from critical food safety limits, you can't just shrug and guess what went wrong. No way. They want to see the exact investigative tool you used and all the records you kept. The SQF uses a really helpful framework called RIO, records, interviews, and observations, to verify your internal investigation was actually thorough. First, records. They'll check your deviation logs and corrective action programs. Second, interviews. They'll talk to your internal audit teams and ask them point blank how they knew when they finally hit the true root cause. And finally, observations. They want to see physical evidence that root cause analysis is actually being used to proactively improve your food safety systems, rather than just reacting when things catch on fire. And this mindset aligns perfectly with the FDA and the Food Safety Modernization Act, or FSMA. The FDA relies on these standardized RCA protocols to inform industry-wide best practices. By doing a really thorough root cause analysis, you shift your entire facility's focus away from just putting out fires, and you move towards system-wide proactive prevention and continuous improvement. It's a real game changer. So as we officially close this case file, I want to leave you with one final thought. When the next deviation happens on your production floor, and trust me, it will, are you going to just settle for the easiest answer? Or are you going to adopt a proactive detective mindset, grab your investigative toolkit, and relentlessly hunt down the true systemic failure? How will you investigate your next operational failure to catch the true culprit before a simple error becomes a major emergency? Thanks for joining us on this explainer, and keep asking the tough questions.